So the title that Don asked me to speak to is How Technology Will Open Up Access. And I'll say quickly a bit about myself. I work for the Association for Learning Technology. We're a professional and scholarly association that has over 800 members, of whom over 200 are organisations and the rest are individuals. And they're basically organisations and individuals who are interested in the application of technology to teaching and learning. I'm a learning person rather than a technology person, but I drew the straw of this talk, so thought I should make that clear at the start. So I start with this fantastic picture of blackboards from a film by an Iranian filmmaker, and I've chosen it partly because blackboards are a learning technology, partly because there's a road ahead in the picture, and partly because the blackboards in the film were never used for their intended purpose. And quite often that's what we find with learning technologies, is that they finish up, we're using technologies that weren't designed for learning, were designed for other purposes. So what's this talk about? What I'm hopefully trying to do is to provide you with a wider context in which to think about your work in learning and development. With luck, what I say will complement Jay's presentation. It might not, we'll find out. We haven't done much by way of comparing notes. And rather than break the flow at the start with what I've learnt in the last 10 years, which I think Don asked us to do, I'm going to build a few points of that kind in as we go along. So the main headings of my talk are to talk a bit about the falling cost of processing and its impact, a bit about ubiquity and the way in which the internet and devices that connect to it are everywhere, and then touch on the role of open source and open content with, and it's in brackets for a reason, a bit about snake oil and how to deal with it. I've brought a kind of reference sheet that's multiple copies, but not quite as many as there are people in the room, I think, on the stage. But if you Google me, you can download it from my website and you'll find me very easily if you want to follow up on some of the points that I'm making. So, first of all, this is Gordon Moore, who co-founded Intel, the chip-making company, in the early 90s, with a guy called Robert Noyce. And he came up with something which is known as Moore's law. This is his original diagram. And Moore's law is a prediction that the number of transistors on a chip will double, that can be economically produced, will double roughly every 2 years. And he came up with it in 1965, thinking that it might hold for 5 or 10 years, but in fact it has held good or better for 40 years, and the tipping is it'll hold for another decade or two. And this has got enormous practical implications. If I'd not taken my jacket off, I would be holding up a memory stick, imagine my memory stick, that I bought in 2000, that cost me 120 quid, and held half a gig of data. It was a real absolute top dollar memory stick when I bought it. And for that money, I can now buy a fully functioning small computer. These one laptop per child laptops and their development in 2005 to 7 for educational use sparked industry into producing netbooks, which many of you have bought in the last 18 months, these small, light computers, probably mainly for home use. 11 million of those were sold last year, and the market this year is predicted to be for 20 million of them. They've kind of taken off like a rocket, and what they show is how Moore's law, that is, getting more and more processing power into a smaller space at lower cost, enables you to do the same for less. This is my G phone, which is an open source smartphone with a Google operating system on it. It's got no backspace button, which is a totally annoying feature of its keyboard that you can't move the cursor around with much ease. But what that G phone has got in it is the size of a bar of chocolate, and that's a diagram of its operating system and the applications that it runs. And it's basically the situation now that phones are becoming like PCs, only with more stuff on them. This has got camera, GPS, all those components. And what sits behind the fact of devices like this is Moore's law. I don't know how visible this is. I hope it's reasonably visible at the back. This is a graph that the founder of the Carnegie Mellon University Robotics Institute produced. And he's someone who believes, I don't, but he does, and he knows much more about it than I do, but I still don't believe it, that machines will have animal capabilities early in this decade, so 2020, 2030. And he kind of shows how, as you move from left to right through time and from bottom to top on a logarithmic scale, the kind of capacity of computers is approaching the capacity of the brains of different forms of life. And sort of his argument is that in the middle of this century, there will be computational capacity available cheaply that will completely dwarf what is already available now. Whatever the truth about his speculation that this will come about, machines can do a lot at the moment that is pretty scary in terms of its creature-like capability. And that's all Moore's law and the software that's running and various other bits of technology that are enabling that. So you've got what's happening in the technology field and then what's happening in the sense of ubiquity. I'm going to work through some data quite quickly. This chart shows that in the UK, getting on for 80% of households have PCs. This chart shows that in the UK and for various other countries, the bottom row, the red arrow shows where the point I want you to look at, that a quarter, there's one broadband connection for every 4 citizens in the UK now, completely changing where we were a while ago. Some data about mobile phones. There's been a 37% annual growth rate in the uptake of mobile phones since their inception in 1990, such that now more than half the world's population have a mobile phone. There are gaming devices in their millions in the UK. These are 2007 figures, and they're undoubtedly low for where things stand now. I'm going to skip this because of time. This is a quote from an interview with Eric Schmidt, who's the chief executive of Google. He alludes in this quote to what he describes as an architectural shift in the way that IT is organized. He highlights that with this new architecture, where you're always online, every device can see every application, and the applications are stored in the cloud. Now, we need to look at this a little bit from the learner's point of view, and this is one of the things that I have learned in the last 10 years that's really affected me and my kind of perceptions of these issues. This is a chart produced by Roy P. from Stanford, and it shows the citizen's life running left to right and the proportion of their waking hours that they are in the developed world in formal learning. And what you can see is this kind of thin strip of formal learning and training and this great big sea of opportunity to learn informally. Overall, the context in which we sit, in which citizens sit now, has changed so that we've got the availability of resources to support informal learning. The nature of those resources is changing, their price is falling, the ease with which you can discover them is changing, they're getting much easier to find, and the existence of devices on which you can render them on is changing so very fast. This is my other, it's not my only learning point in the last 10 years, but Dylan William, who's Deputy Director of the Institute for Education and used to be the Research Director for Education Testing Services, a company that lost a contract recently in the UK for marking SAT tests, but a very sorted out bloke, said this in a keynote he gave at our conference in 2007, and I'm going to read it, or part of it. Most teachers behave as if they create learning, but in fact, learners create learning. Teachers create the conditions under which learning can take place. And it's true for teachers, it's true for trainers, and his take is that that's what we need to kind of have in our perception when we're planning and organising. Yet often we're faced with diagrams like this when we talk about technology in teaching and learning. This is quite an old diagram, but it shows a sort of discrete system called a learning management system squirting know-how into the brain of the learner. And it's got no bearing, really, with either the way people learn or what's available now by way of ubiquitous infrastructure and content for them to learn with. This is Walter Lewin, who's Professor of Physics at MIT, and millions of students and others have watched videos of his lectures, which are freely available on the internet. And if you can tolerate this rather grainy shot or
piece... Any good teacher can turn physics into something absolutely spectacular. And this powerful rocket is enough to reach the escape velocity of 26,100. I almost reached the escape velocity, but I crashed. See you next Friday. I rehearse every lecture 3 times in real time with an empty classroom, with empty blackboards, and I write on the blackboards everything that I would be writing down during my lecture. And that takes about 40 hours per lecture. And of those 40 hours, there are 3 dry runs involved. 3 complete, full-time dry runs.
So this is an example of some open content, and I'm turning now from we've done the technology, we've done the ubiquity, we're turning to the open content and the open source. Before I say more about open content, I'd like to say a little bit about open source software, and I'm going to lapse into bullet points to a degree, but I'll be as speedy as I can. First point to make is that open source software sits behind much of the ubiquitous internet. Google's supercomputer of linked server farms runs on open source software. My G phone uses it. Many of these new netbooks use open source software. Most of the world's web servers run on open source software. Secondly, open source software plays a key and direct role in e-learning. Let's see, Moodle, a very, very prominent open source virtual learning environment, has the most installations worldwide of VLEs. The University for Industry runs its infrastructure, which has 2 million online learners using principally open source software. Wikipedia, which you'll all have used, hopefully you'll all have edited, is running on open source software. The platform for Wikipedia is an open source application that you can download and use for yourself if the will takes you. And the final point to make is that the success of open source and its feasibility flows largely from the fact there is this architecture of ubiquity, because big teams of distributed people all over the place might be contributing to the creation of one piece of software, and you need the internet and the tools that it provides to enable them to communicate with each other and do the job. So that's a quick snapshot pertaining to open source software. And I'm now going to switch to open content. Open content is essentially freely available information and learning resources like the Walter Lewin videos, but can be much less complicated than that. And I'm wanting here to indicate why the learning and development community needs to take open content seriously. The first point is that learners will use it whether you like it or not, whether we like it or not. So we might as well make it good. The second thing is that it enables stuff to be done at scale. You work for companies and organizations of varying sizes, and many of you are working in quite large-scale contexts, but it's nevertheless the case that there's an awful lot still of cottage industry, and certainly in public sector education, teachers and trainers, making stuff quietly on their own rather than teaming up, pooling together. And open content enables that to be done. And a head of steam is developing behind the creation of open educational resources. Now, I want to just make a caution about this, because I feel there is a tendency for people in our world to portray open education resources as a panacea. And my 3 points in relation to that are: the parallels with open source software are not so very close, first point. Second point, that software is modular in a way that learning materials rarely are. And thirdly, that there are cultural and organisational challenges relating to the use of open education resources in formal education. Where it might work, I put forward these 4 possibilities. So an organisation might need the same stuff to be used widely across it, and open content approaches can be used there. You might need small good snippets that make a difference, for example, diagrams, how a petrol injector works. There's no point in loads of different companies separately producing that. There's much easier to deal with that as an internet resource that can be accessed widely. There are learning activities which are effectively teacher or trainer how-tos, rather than the content that's used in the learning, which can well be made available in that way. And then finally, we get these big initiatives like MIT's decision to put its stuff out into the public domain. I'm going to skip snake oil because time is short and I don't want to eat into Jay's time. Quick summary. Moore's law: faster, cheaper, smaller, more powerful. In the next 10 years, 64 times more powerful. In the next 24,000 times more powerful. Exponential increase in power, and a 4,000-fold increase in the power of computing in 20 years. That's a very, very big change. The architecture of ubiquity: nearly everyone will have an always-on device always connected to the internet. Openness of software, yes, of content in some circumstances. I'm going to conclude now with a cautionary note, which links a little bit back to the keynote speaker we heard earlier. It's about time. If you take the several million years in which there have been vertebrates on the Earth and spread that over 2 hours, then there's been, within the period of vertebrate life, 1 minute of tool-making humans. If you take the period in which there have been tool-making humans, 200,000 or 300,000 years, there's been 30 seconds of farming and 15 seconds of recorded history. It's the same creatures, their brains have not changed much in that period. If you take the period in which there's been recorded history, spread it over 2 hours, we've had 18 minutes of printing. We've had PCs for 40 seconds, the web for 22 seconds, and the 3G-enabled iPhone for 3 seconds. And I put this up because it's so easy to get carried away with all this technology stuff. And we might feel viscerally, and in a sense my talk argues that the internet changes everything. But I think what this shows is the internet changes nothing at the same time, and that you should not get carried away. And I'll close with that.
Thank you very much.